Voyager 1 has sent inexplicable signals to Earth that NASA describes as abnormal. Together with its identical sister probe, the NASA veteran has revolutionized our understanding of the outer solar system and is known to have even penetrated into interstellar space. But what has now happened to Voyager 1 in the depths of space? Have we finally received an answer to the Voyager golden records? Or has Voyager 1 even fallen into the hands of an extraterrestrial civilization? Stay tuned until the end and find out with us. 24.91 and 20.84 billion kilometers. These are the almost unbelievable distances that NASA's Voyager 1 and 2 probes have put between themselves and the Sun since their launch in 1977. No other man-made object has ever ventured so far into the cosmos, and it's in the nature of things that the advance into interstellar space is also linked to data that is absolutely unique to date. And yet we should not forget that Voyager 1 and 2 have also helped us significantly to shed more light on our planetary neighborhood. After all, what today represents the most remote outposts of humanity was not originally developed to break the boundaries of the solar system at all, but merely to gather new information about the outer planets of our home world, which were still largely unexplored at the time. And to say that Voyager 1 and 2 fulfilled this task would be an understatement. The twin probes actually set up dozens of milestones on their research trip and collected measurement results, many of which are still unique today. After all, there is still no other probe besides Voyager 2 that has visited all 4 outer members of our planetary system. And at the same time, Voyager 2's detour to Jupiter, Saturn, Uranus, and Neptune also made it the first and only spacecraft ever to have headed for 4 planetary destinations. The cosmic old-timer still has exclusive access to Uranus and Neptune, and we owe almost everything we know about these ice giants to its data and images. This includes, for example, the unusual quadruple magnetic field of the 2 celestial bodies, or the massive ice mantle that surrounds the small cores of these planets under the dense atmosphere. But the Voyager probes are also second to none when it comes to moons. After all, no other mission has added as many new satellites to the star charts as these 2. Together they discovered 3 new moons of Jupiter, 4 new moons of Saturn, 11 satellites of Uranus, and 6 moons of Neptune. And one of them, the moon Io, even became the first celestial body other than Earth to be shown to have active volcanoes. Voyager 1 also holds the title of the first space probe to observe lightning on another planet, in this case, in the atmosphere of the mighty Jupiter. Voyager 2, in turn, provided us with the first images of the rings of Jupiter, Uranus, and Neptune. But the mission also delivered the first evidence that the Jovian moon Europa hides a full-fledged ocean beneath its surface, and thus an underwater world of its own in which extraterrestrial life may already be flourishing. Why interstellar space is much stranger than we thought. All the records and insights on our own doorstep were undoubtedly groundbreaking. But at the same time, they are now already just yesterday's cosmic news. As already mentioned, the probes have now been traveling in interstellar space for several years and have brought equally astounding things to light there. However, in order to properly classify the corresponding discoveries, we should briefly acquire some basic knowledge. The simple fact is that the Sun is not a rigid celestial body that radiates motionlessly, but rather a nuclear furnace that races through space at a speed of 725,000 kilometers per hour. Dynamic magnetic field lines extend around our source of warmth and life, along which plasma currents, so-called solar winds, constantly escape. These solar winds permeate our entire home system and eventually reach the interstellar medium. The particles, magnetic fields, and radiation that were ejected during and after the Big Bang and still exist in the space between the stars today. However, the solar winds and the interstellar medium do not mix evenly, but rather like oil and water. Instead, the solar winds form a bubble within the medium, the so-called heliosphere. The Voyager data show that this extends about 18 billion kilometers around the Sun. At the same time, however, the heliosphere also acts as an important protective shield because it shields everything inside it from a large part of the cosmic radiation. The outermost part of this structure, the heliopause, is also referred to as the border of the solar system. This is where the interstellar space begins. And when Voyager 1 entered this very area in 2012, it immediately raised big question marks over the heads of the experts. For example, the interstellar magnetic field was in fact 2 to 3 times stronger than previously expected, which in turn means that the pressure exerted by interstellar particles on the helipause is up to 10 times more intense than assumed. And yet, the insight provided by Voyager 1 also had a major catch. It was incomplete. In fact, the instrument responsible for measuring the plasma temperature has been defective since the 1980s. But fortunately, it was still intact on board Voyager 2. And so it happened that the second foray into interstellar space, which took place in 2018, proved to be even more revealing than the first. Since then, we have known what happens when an object approaches the heliopause. The surrounding plasma slows down while simultaneously becoming denser and hotter. However, the plasma is so thin and irregular in nature that the temperatures around Voyager 2 were surprisingly low. This did not apply to the interstellar medium itself, however. At almost 30,000 degrees Celsius, it is much hotter than previously thought. In the same breath, the data collected by Voyager 2 showed that the plasma from both sides of the heliopause spills over into the other area. The experts state that this presents itself in the form of a stream of low-energy particles that extends 160 million kilometers into the heliopause. Another fact that left scientists raising their eyebrows was what the probes had experienced during their approach to the heliopause. Voyager 1 had entered a relatively static area at a distance of around 1.3 billion kilometers, where the solar wind had slowed down rapidly. Voyager 2, on the other hand, passed through an area that was in stark contrast to its comparatively static counterpart. Heliophysicist Patrick Kahn, who works as a program scientist at NASA headquarters, summed up the researchers' confusion as follows: "This is really quite strange. It proves to us that we absolutely need more data." A statement that not only points to the different discoveries made by the two probes but also to the fact that our overall picture of the heliosphere still has enormous gaps. In fact, we don't even know what shape this structure has. It may be spherical, but it's also conceivable that it resembles a croissant or has a comet-like tail. The inexplicable message from Voyager 1. The last thing you would hope for in the context of such an ambitious mission is a probe that suddenly goes haywire. But unfortunately, Voyager 1 did just that a few years ago. Specifically, the elderly spacecraft suddenly started sending a chaotic jumble of data to Earth that simply didn't make sense. Once the news had spread, it wasn't long before the internet community was looking for explanations for the confusing messages. And in the usual manner, they didn't shy away from, well, rather unconventional approaches, from an extraterrestrial civilization that had intercepted the probe, to aliens that had reprogrammed Voyager 1 and sent it back to Earth with a declaration of war. The internet was full of all kinds of wild speculation. But what had really happened? Well, the good news is that we have been spared the war of the worlds so far. The bad news, however, was that the signal seemed to be a complete mystery to NASA experts. It appeared that the chaotic telemetry data was generated completely randomly. The data from the attitude articulation and control system indicated a system failure. But apart from that, the probe was working perfectly. The corresponding attitude and orbit control system is responsible, among other things, for pointing Voyager's main antenna precisely at Earth, because only in this way can communication over such a vast distance be ensured. In view of the nonsensical AACS data, it was all the more surprising that the data transmission from the scientific instruments went as usual, and Voyager also continued to respond to Earth-based commands. Since the signal strength of the radio connection was also unchanged, the main antenna had to continue to point towards Earth. But what was the problem then? Fortunately, a few weeks later the experts were able to locate the bug and crack the mystery of the mysterious data sets. First of all, NASA engineers found out that the attitude control system was actually working perfectly well, with one exception. It was trying to send the telemetry data to Earth via an onboard computer that had not worked for years. The result was that the information arrived at the Earth stations as scrambled data garbage, causing nothing but confusion. Once the cause had been uncovered, NASA used the radio antennas of the Deep Space Network to command the AACS to transmit the data to the correct, intact onboard computer in the future. This worked, and the experts were once again able to enjoy consistent telemetry data. And yet a mystery remained. What had caused the attitude control system to resort to the wrong computer in the first place? Well, in this regard, the NASA staff could only speculate at first. It's possible that the cause was a faulty command from another component of the onboard electronics. In the period that followed, however, it became clear that the error-prone computer was apparently in the so-called flight data subsystem, a computer that packs data into the packets before sending them to Earth. As it turned out, 3% of the memory was defective, and NASA suspected that a single chip could be the source of the error. This could either have been hit by a high-energy particle or was simply worn out. And now you can wear out the subscribe button with your high-energy click. Just press the thumbs up and subscribe now to never miss a new video from our channel Insane of Curiosity. We'll see you soon.